true projects. In this video, we are going to explain about a project titled Flavor Classification using Deep Learning. Our project is to create a sophisticated system that can precisely recognize and classify the flavor in the images. Using the convolutional neural networks and the deep learning technique, we plan to develop a strong model that is trained on a wide range of flavor images from the diverse datasets. Our innovative approach aims to achieve the remarkable accuracy in identifying the different flavor species, not only benefiting the potential flavor species, but also have significant implication for the environment monitoring, biodiversity conservation, and creative endeavors. By employing the cutting-edge deep learning method in flavor classification, we aim to deepen our knowledge to the flavor classification to floral realm and drive progress across the various fields of the study. Our main goal is to construct an advanced flavor classification system that achieves high accuracy and adaptability. To do this, we will utilize the cutting-edge deep learning algorithms such as Inception ResNet v2, DenseNet, ResNet, and the Inception v3. By exploiting the distinctive architecture characteristics of these models, we will train them on the diverse dataset of the labeled flavor images, enabling them to learn, intercept the patterns, and differentiate among various flavor species. Our project aims to assess and compare the performance of each algorithm and identifying the respective strengths and weaknesses in the flavor recognition task. Additionally, we plan to create an ensemble model that combines the prediction of these algorithms to further improve the overall classification accuracy. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB and above. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. And importing the library, this step involves importing the necessary libraries and the frameworks for the deep learning and the image processing. This includes the Python libraries such as TensorFlow, Keras, NumPy, and others. And the second one is importing the dataset. A diverse dataset containing images of different species is collected and imported. This dataset will be used to train the deep learning model to recognize and classify the various flavors. And the third one is image scaling and processing. The imported flavor images are pre-processed, which includes tasks like resizing the image to a standard size, normalizing the pixel value, and other image processing technique to enhance the quality and the consistency of the dataset. The fourth step is splitting the dataset. The dataset is divided into the two sets, a training set and the testing set. The training set is used to train the deep learning model, while the testing set is used to separate and to evaluate the performance of the trained model. And the fifth step is applying the algorithm. And the various algorithms are applied. The first one is Inception v3 model. And this a convolutional neural network architecture which is developed by Google. It is based on the idea of using the multiple parallel convolutional layers with different filter sizes to capture the various scale of the features and the input images. This architecture is known for its efficiency in terms of computational resource and high accuracy in the image recognition task. And the second one is Inception ResNet v2. It is an extension of the Inception architecture that incorporate the residual connection inspired by the ResNet architecture. Residual connection help address the vanishing gradient problem during the training deep networks and allow for the easier optimization of very deep models. InceptionNet v2 combines the strength of both Inception and the ResNet architecture, leading to the improved performance and various image recognition tasks. And the third one is DenseNet. It is a unique CNN architecture that introduces the dense connection between the layers. In DenseNet, each layer receives input from all the preceding layers, resulting in dense feature reuse and the information flow. This architecture enhances the flow of gradients during the training, encouraging the feature reuse and elevates the vanishing gradient problem, making it easier to train very deep networks where DenseNet has shown excellent performance with relatively the fewer parameters and making it computationally efficient. And the fourth one is ResNet. ResNet, as a short form of residual network, is a grounding breaking CNN architecture that introduced the conceptual of residual block. These blocks contain the shortcut connection, allowing the network to skip one or more layers during the training. This mitigates the vanishing gradient problem and enables the successful training of extremely deep networks. ResNet is widely used in the image recognition task due to its ability to effectively handle the deep architecture and achieve high accuracy. These four models have proven to be effective in the flavor classification task when trained on the diverse and labeled flavor image dataset. By leveraging their unique architecture features, researchers and practitioners can build and robust and accurate flavor classification system. And the next step is training the model. Each algorithm is trained on the training dataset using the labeled images. The model learns to identify the pattern and the features that distinguish the one flavor. And the next step is user gives input. The system is integrated with a web application built using the Flask framework. This allows the user to give the input images of the flavor through a user-friendly interface. And the next step is the given input is pre-processed for prediction. When a user submits an image, the input image is processed to match the format required by the trained deep learning model. This step ensures that the user input is compatible with the model for the prediction. And the next step is trained model is used for prediction. The pre-processed input image is fed into each of the trained deep learning model of Inception v3, Inception ResNet v2, DenseNet and ResNet. Each model predicts the flavor species based on the input image. And the last one is final outcome is displayed. The prediction from all four models are collected and analyzed. Depending on the approach chosen, the majority voting or the weighted voting, the system combines the prediction to generate the final classification result. The predicted flavor species are then displayed to the user through the web application, providing the final outcome of the flavor classification. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the different folders and the files within it. The flavors folder is a data set containing of the different folders consisting of different named flavors within it in the form of the images. And the output folder containing of the training and the val folders containing of the flavors within it. And the static folder containing of the various folders like of CSS, JavaScript, images, models and bootstrap files within it. And the template folder containing of the HTML documents like of after, home, index, sign in and sign up pages within it. And the app is an py file likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains a combination of the code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And the model 2 and model 3 is .h5 file which contains the algorithm information, and this will be loaded at the time of execution of the project, and it's used for doing the certain tasks such as of predicting the new data. And for execution of the project, we build an Flask framework web interface, and the overall code like of graphs and output all are present in the notebook IPYNB file. And first execution of the project, we need to copy this code folder path and open the Anaconda prompt. Here first we need to change the disk path as of F because our code folder is present in fdisk, and then write a command cd space and paste this address of the code folder. By this the directory will be changed to the code folder's path, and then click on enter button. After this we need to write another command, which is python space app.py. By using this command, it will execute the Python script, perform and runtime check for any syntax errors or the logical issues, and then click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address and giving an like this. And we need to copy this local link and paste it on any of the web browser as of our choice, and I prefer to use the Chrome. And I paste this link and then click on enter button. Here this is the home page content of the sign up button. Click on the sign up button. It will be redirected to the sign up page, contains of the various necessary details that are need to be filled to create an account. But my account is already regenerated, that's why I'm using the sign in button and enter the username and password as of admin. And then click on sign in button. Here we redirect it to the index page containing of the choose file and upload buttons. Here click on the choose file button. It redirected to this folders containing of the test images, and select any one of the image and then click on the submit button. And then click on upload button. Here it generated that image is predicted as STLIF, and this way we were using the try again button. It redirected back to the index page of containing the choose file and upload buttons, and select the choose file button, and it redirected to this folder containing of various images within it, and select any one of the image and then click on open button, and then click on upload button. It will redirect it to the result page containing of predicted result as water lily. And by this we can again try this button and then choose file and select any one of the image and then click on open button and then click on upload button. Here the predicted image is predicted as of bell flower. In this way we can predict the various flowers by using the deep learning technique. And in conclusion, our project uses the deep learning techniques with Inception ResNet v2, DenseNet, ResNet and Inception v3 as yielded the remarkable result in the realm of computer vision and artificial intelligence. By harnessing the power of cutting-edge deep learning algorithms, we have developed a highly accurate and versatile flavor classification system, and enabling the precise identification and the categorization of the various flavor species from the images. Success of this model further solidifies the significance of combining the multiple algorithms for improved classification accuracy, with implications in botany, environmental monitoring, and beyond. Our project holds promise for advancing research in the flower recognition and the contributing to biodiversity conservation efforts. As we continue to explore the potential of the deep learning, our work opens doors to innovative solutions in the diverse domains, propelling the field of artificial intelligence to the new heights.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.